Hello guys, so in this video I'll be talking about half reactions. We are still doing reactions in aqua solutions, which is redox reactions. Redox reactions, okay. So to be specific, in this video I'll be talking about what is called half reactions and balancing. So two things will be done in this video: half reactions and balancing redox reactions. Okay, so this is what we'll focus much on in this video. Now let's begin, guys. We know that if you go back to my previous videos, we talked about a redox reaction, and we said a redox reaction, just to make a recap, it has oxidation process and reduction process. Now, so those two processes there, if we can separate them and if we can identify them, they become what is called half reactions. Okay, so what happens is this. Remember, we defined what oxidation and reduction are in terms of oxygen, electrons, and so forth. Go to the videos, you find everything there. Now, so between the two reactions, one half reaction, this is what we have to know. One half reaction produces electrons. Okay, remember we said what is oxidation in terms of electrons. We said it is the loss. So meaning, what it means that it produces electrons. You are going to have a reaction A plus B. If you say it produces, it means that electrons, if electrons are lost, meaning you're going to have C plus the electrons on the right side of the equation, meaning the half reaction which produces electrons is called what? Oxidation half reaction. Because it is the loss. Loss means that the electrons beware on the right of the equation. Okay? So that is one of the half reaction. Then the other one half reaction does what? Requires electrons. So this one requires electrons, and what that means is that when I have a reaction, if you say it requires, it means I'm going to have A plus the electrons, so that I can have C plus D. Remember we said in terms of electrons, a reduction is the gain. So this plus means the electrons are gained. So this is the reduction. The one which requires electrons is what is called a reduction half reaction. Okay? Now, this is what we mean by the half reactions. One will require the electrons, then one will produce the electrons. Now, let's proceed. Those are called half reactions. What if I have a reaction, let's say this plus this, giving me, this is chlorine, then giving me 2 sodium plus 2 chlorine minus. Okay, then I ask it to say identify the half reactions. What do? So what you can do here is, this is the easiest way. You are going to use oxidation numbers. Okay, use oxidation numbers. So what did I say? When you have an atom like this, the oxidation number for this one is what? It's 0. Then when you have a diatomic like this, it's what? It's 0. All right. Then here, when you have a charge like that, what's the charge? It's positive what? Positive 1. Like that. So in this case, you can even say positive 2 because you have 2 times there. So this is positive what? Positive 2. Positive 2. Then this one here is negative what? Negative 2. Then you have to compare them. Sodium versus sodium. Remember what you can have on this side and what you can have on that side. Then we also compare this. You do this. All right. Now remember, in terms of the oxidation numbers, we defined what oxidation is and what reduction is. So we said oxidation is an increase of the oxidation number from the reactant to the product. So look at here, from 0, like this one, from 0 to positive 2, this one here, from 0 to positive 2, what's happened? This is an increase. So this means that this is the oxidation half reaction, this is the oxidation process. Okay, then chlorine to this one, it means that there is a reduction. From 0 you're going down, this is a decrease. Okay, from 0 to negative 2, that's a decrease. So this is a reduction half reaction. Guys, it's very easy to use oxidation numbers to tell which one is your oxidation process, half reaction, and which one is your reduction half reaction. Okay, so this is what we have. Then we are going to copy these two equations like this. All right, we are going to copy them. So you write like this now. So half reactions, it's very simple. Use oxidation numbers. Go back to the rules that I gave there in my previous video. So in this case, we have the oxidation one. You write that was 2 sodium, giving you what? 2 sodium what? 2 sodium plus. Then for the reduction one, what do we have? The other side, I think that was chlorine. So there is chlorine 2, then giving us 2 chlorine negative. Okay, so these are the half reaction. So this is how you tell to say this is oxidation half reaction and this is reduction half reaction. The combination of these two forms what is called a redox reaction. So guys, this is how we identify. It's very easy. Okay, it's very easy. It's very easy. Maybe I give another example. How do you identify the half reactions? Right, let me give another example. What if I have this reaction? Yeah, what if I have the following reaction? How can you identify the two half reactions? Okay, let's do this because this is very important in our next lesson. Okay, what if I have this reaction Fe 2, this is reacting with carbon monoxide, giving us carbon dioxide plus iron. This equation we are familiar with it in a blast furnace. Okay, how do you balance this one? How do you balance this one? What are we putting here? Are we supposed to add a 3 here, a 3 here? And does that make sense, by the way? If you put a 3 there, yes, then I use a 2 here. Is the equation balanced? Of course, I'm also going to show you on how to balance without what you're doing here. But anyway, here I can also remove these. It's okay. We can have an equation like that. It's fine. Now we want to find out which one is the oxidation half reaction, which one is the oxidation half reaction. So I said use oxidation numbers, guys. So in this case, we know for oxidation. So what you do is you assign the oxidation states to all the atoms in the reaction. Then you check. Look at it. So oxygen here, it has what? Negative what? What did we say? Negative 2. So in here it's negative 2. Then for iron, you have to calculate it. How? You say 2 multiplied by x plus, how many oxygens are there? 3. Multiplied by what's the oxygen state of this one? Negative 2, which is equal to what's the net of everything? What's here? There's nothing, so that means there is 0. So you say 0. Then this are going to say 2x is equal to 6. This multiplied by that, you're going to have positive 6. It means that x is equal to what? Positive what? Positive 3. So for iron here, it is positive what? Positive 3. Okay. Then for oxygen, again, we say we don't calculate. So in this one, we have negative 2. Okay. Then for carbon, how many carbons are there? It's 1 multiplied by x plus, how many oxygens are there? Just 1. Multiplied by what? 1 multiplied by, what is for oxygen? Negative 2, which is equal to what's there on top? It's 0. This means that x is equal to positive what? Positive 2. So here we have positive 2 as a charge. As the oxidation number for what? For carbon. Then move on again. Oxygen we don't calculate. It's negative 2 in this compound. So how many carbons are there? So 1 multiplied by what? X plus, how many oxygens are there? 2 multiplied by negative 2 is equal to, what's there on top? 0. There's nothing, means 0, the entire one. So x is equal to positive what? Positive 4. So in this way, carbon is positive 4. So in there, carbon is positive 4. So carbon is positive 4 here. Okay, then oxygen negative 2 there. Then iron there is just alone. So what do we have? It's a 0. Now you have to compare element on the left and elements on the right. So let's start with, you can't use oxygen because oxygen is not changing. You can't use hydrogen because hydrogen doesn't change. So I'm going to use this one, iron versus iron. Where there's iron there, you get? Then here I'm going to use carbon versus this carbon which is here. Now let's identify. From positive 3 to 0, what's happening? Going down. So this is what? This is what? Reduction. So this is reduction. Okay? Then reduction. So the process is what? Reduction. Then from positive from positive 2 to positive 4, this is what? That's an increase. So this is what? Oxidation process. So that is oxidation process. Now guys, remember I said oxidation, the one which is undergoing oxidation, it means it is been what? Oxidized. And since it's been oxidized, what agent is this? It is a reducing what? Agent. So this is how you identify. When even ask you to say, identify the oxidizing agent, reducing agent, and so forth, this is what you have to do first. To find the reduction process, which one is undergoing reduction process, and which one is undergoing what? The other process. Then the one which gets oxidized is the reducing agent. The one which gets reduced, what did you say? It is what? It's the oxidizing agent. Now look at here. This is an amazing process that we know. Carbon monoxide, we normally use it here as a reducing agent. This is how you tell. So now from here you have identified the oxidizing agent and reducing agent from the two. That's how you tell. Now, so this one, we had this one to this one. It is an oxidation process. I mean, no, it's a reduction. What? It's a reduction process. Yeah, this is a reduction process because positive 3 to 0. So that's a reduction. That's a reduction. Then from positive this is oxidation. So now let's write them. How do you write the half reaction? So I'm going to say, okay, oxidation half reaction. Right? You say ox. What is there? You say for oxidation, what's there? You write the whole compound. Carbon monoxide giving you what? Carbon dioxide. You've seen. Then you say reduction half reaction. Just for the arrows that you've done, you say Fe what? 2 or 3 giving what this side? Ion. Like this. So this is how you identify. This is how you separate the half reactions. Easy. So use oxidation numbers. You're able to tell the decrease, increase. Don't use oxygen to compare. Don't use hydrogen to compare because those, they don't change anything. Guys, so this is all about in this video. So just about identifying which one is the half reaction and which one is the oxidation half reaction. Use the oxidation numbers. Assign the oxidation numbers to each and every atom that is present in the reaction. Then from there you compare the decrease, increase. Remember what we talked about in the previous videos. Then you've identified. So in my next video, I'm going to show how we balance now these reactions.